so for the first example, it says for the following logarithmic function, g of x equals to 2 log base 10 x minus 3 plus 4, we have to describe the transformations that must be applied to our base function y equals to log base 10x to obtain the graph of g of x. So let's go ahead and start off by doing that question. So for the first part, I'm just going to start off by writing down what g of x is. So g of x is equal to 2 log base 10 x minus 3 plus 4. So when I'm describing the transformations, I'm going to be looking at the parameters and what their values are and specifying what that means. So for first part, the 2 right here means it's a vertical stretch by a factor of 2. So I'm just going to write that out. It's a vertical stretch by a factor of 2. And as I'm going across towards the right hand side, the next parameter is my d value, which is represented by a positive 3. That means it's a horizontal shift of 3 units towards the right. And my last parameter, which is the c value, is a positive 4, so it's a vertical shift 4 up. Okay, and the second part of the question says, sketch the graph of g of x. So when I'm sketching the graph of g of x, it's very important that we allocate what our key points are and what the transformed key points are, along with our vertical asymptote. Let's go ahead and start off by doing that. So in this case, my key points, x and y, log base 10x, that's a function that I'm going to be classifying as my base function. And my y key points are always going to be 0 and 1. So I have to figure out what did my x values have to be such that my y value is 0 and my y value is 1. Along with that, I am going to also draw my table of values for my transformed function. And as we know that the a as well as the c value affects my y values, I'm just going to carry that out by writing down the equation for the transformed y value. That's 2y plus 4. And the only thing that's affecting my x, or my horizontal shift, is basically this 3. So that's x plus 3, so I'm shifting my graph 3 units towards the right-hand side. Okay, so let's go ahead and figure out what those x values have to be, along with what our transformed table of values are going to be. I like writing down my logarithmic function and 10 exponential function, so just writing that out would be 10 to the power of y is going to equal to x. Using that piece of information, so 10 to the power of 0 is basically going to equal 1, and then 10 to the power of 1 is going to be 10. Transforming that, I'm going to take this x value, which is 1, plus 3, that is 4, and then 10 plus 3 is 13. You're doing the same thing with the y coordinate. 0 times 2 is 0, plus 4 is 4, and 2 times 1 is 2, plus 4 is 6. Once that's done, I'm also going to classify what my vertical asymptote is. My vertical asymptote here is x is equal to 3. Okay, let's go ahead and sketch this out now. So when I'm sketching this out, I do want to keep in mind my minimum and my maximum x value, along with my min and max y value. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I do want to go all the way up to 13 because that's one of the coordinates that I do want to plot. And for y value, this is going to go up all the way to 6. So it's 1, 2, 3, 4, 5, 6. Okay, so I'm going to start off by first allocating what my vertical asymptote is. X equals to 3. So that's x equals to 3. And the two coordinates that I want to plot is 4 and 4. And the next one is 13 and 6. Now I'm just going to join those 2 points and make it approach x equals to 3. That's my function, and I'm going to label this function as g of x equals to 2 log base 10 x minus 3 plus 4. Okay, and question says, state the equation of the vertical asymptote. We have already done that in part A as well as in part B, so I'm just going to formally write it down now. My vertical asymptote is x equals to 3, and my D says state the domain and range, so I'm going to refer to my graph when I'm stating my domain and range. And as you can see from the graph, this function is greater than positive 3, so that is going to be my domain. So it's x such that x is greater than 3. X is an element of real numbers. We're just writing that in set notation. And for a range, the range basically spans all of y-axes. There is absolutely no restrictions on the range, so it's going to be y such that y is an element of all real numbers. Okay, and a last part of the question says, if 102 is a point on the base graph, state the coordinates of the transformed point on g of x. I'm going to, I was going to use a different color pen. Oh, here it is. I have one here. So the 2 points that I want to transform, so one point that I do want to transform is 102. So I'm going to use my table of values to do that. It's 102, and it's kind of hard for you to see. Perhaps, you know what, I'll just do it over here. X, Y, that's 102. I want to see what my transformed point would be. X plus 3, 2y plus 4. So 100 plus 3 is 103. 2 times 2 is 4, plus 4 is 8. So my new point is basically going to be 103 and 8 once the transformations are applied. And that's it for the question. Thank you.